Hi, my name is Sunny Aggarwal, and today I'll be giving a talk called Many Chains, Many Tokens, One Ecosystem. So, just to begin, a little bit about me. Who am I? My name is Sunny Aggarwal, as I mentioned, and I'm a researcher with Tendermint. I've previously co-founded Blockchain at Berkeley and worked at Consensus, and currently live in Berkeley, still involved very actively with the Berkeley community, and I kind of got really interested into this summer into proof of stake and blockchain interoperability. And so, you know what? It turns out that was perfect because I got involved. I met the people at Tendermint, and the Tendermint team's basically working on two major projects, Tendermint and Cosmos, and which just happened to align perfectly with what I wanted to work on, which Tendermint is sort of a proof of stake platform, and Cosmos is a blockchain interoperability platform. And so, over today's presentation, we'll be going into what goes into Tendermint and Cosmos and how these two projects work together to build a internet of blockchains and create a scalable, private, and safe blockchain ecosystem. So, to begin off, we'll talk a little bit about how Tendermint and Tendermint Core works. So, to start off, we'll start with this, what we see here, what I'll call the simplified architecture. This is sort of the software stack that was used in most traditional blockchain applications, such as Bitcoin. What we'll say is a blockchain has three layers to it. Basically, we have a networking layer, often called the peer-to-peer layer, a consensus layer, which would be something like proof of work, proof of stake, maybe a private PBFT instance, or you can have an application layer, which is whatever the state machine on top. So in the case of Bitcoin, the state machine is the Bitcoin application. In the case of Ethereum, the state machine is the EVM. And so you can write your state machine and application in different ways. But in the simplified architecture, what happened was all three layers came bundled together in one software stack. And if you ever wanted to create your own application, it was very hard. You were basically, you usually forked the Bitcoin code base, and using this code base, you had to kind of either write you had to it was a very messy C++ spaghetti code, which was very hard to modify and build into your own applications. So along came Ethereum in 2014, which basically offered the ability to make it easy for anyone to write their own application. So the thing is, most people who are building blockchain applications, they really are focused about their application. They're not overly worried about the consensus and networking layers. And so what Ethereum did was it allowed Ethereum's applications, EVM, to interact directly with the other two, and then you just write your application as a little building block on top of it. But the thing here is you still actually don't have that much fine-grained control over your application. You kind of, in making it easier for you to build, you kind of gave away some of the control that you had in designing the application, because you are now forced to conform to the standards of the EVM. So that's why we created a piece of software called Tendermint Core. Tendermint Core is basically allows you to create your own application. No matter, it could be any sort of deterministic state machine, and then you can run it on top of Tendermint Core, which is a piece of software that handles the consensus and networking layers for you. And it does this by interacting with your application through an interface we've created called the ABCI. And so before we go a little bit more into ABCI, let's quickly take a moment to talk why Tendermint Core. Why should you use, in the future, we're going to see many different consensus algorithms that will probably comply to the ABCI standard. But so, Tendermint Core happens to be one of the first of them. And why did we go with the Tendermint consensus algorithm? So a little bit about that is Tendermint consensus is a scalable BFT consensus algorithm that favors consistency over availability. So the cool thing about what that means is it will never fork. So, unlike Bitcoin, where, you find out a block is finalized after it gets sufficiently deep into the chain. Let's say once it gets 6 blocks deep. at that point you can be reasonably sure it's not going to be there's not a fork that you haven't seen that's suddenly going to overtake it. But this causes you to have these sort of like synchrony assumptions and stuff in Bitcoin, and this probabilistic finality causes really long times till finality, especially for your transaction. So in Tendermint, one of the cool things about how Tendermint works is we actually can have an asynchronous system, but more importantly, every single block is finalized. Once a block is committed, it will not be reversed. And so as soon as you see your transaction on a chain, you can be reasonably sure that you can be 100% sure that your transaction will stay on that chain. Otherwise, or else, a lot of people are going to lose money, and there's a 33% attack going on in the system. So another cool thing about Tendermint consensus is that it can be used easily for both public and private chains. In a public system, it will use proof of stake, while in a private system, it will use permissioned nodes, but still use the Tendermint consensus, which allows you to get this Byzantine fault tolerance with very easy leader elections and stuff. And so it's highly scalable, and the cool thing is it guarantees safety in asynchronous settings. So in Bitcoin, if you had a lot of network latencies, the reason Bitcoin block times are so high is because it's not safe in asynchrony. And so if network latencies were too high compared to block times, the system will never be able to resolve itself. Meanwhile, Tendermint, if you ever have this sort of asynchrony where like suddenly, let's say there's a firewall that goes up, or a large portion of the world loses connection from another part, then the system will still remain safe, and it will stall rather than causing two irreconcilable forks. And Tendermint's sort of the basis for a bunch of other proof of stake systems that are built very heavily off of it, such as Ethereum's Casper. So yeah, let's hop back into the ABCI now that we know what a little bit about the consensus layer of Tendermint Core. And the networking layer is a very standard P2P networking stack. So with the ABCI, what you can actually do is take any VM that you have and run it on top. So for example, for our hackathon that we hosted 2 months ago, one hacker took the chain.com VM, and chain.com's VM is traditionally more of a private chain system. But what they did was they took the VM portion of their software and put it on top of Tendermint consensus, creating a fully it's a proof of stake version of chain.com, or it's a Tendermint version of chain.com system. So while it doesn't have the features of proof of stake yet, it still has all the Byzantine fault tolerance that Tendermint provides. You can take a Zcash and add it on top of Tendermint consensus. This is what I'm just doing here is showing examples of like how you can take state machines that are based off of other consensus algorithms and put them on top of Tendermint Core. One thing that we did was we took the Ethereum state machine, the EVM. We basically took the Geth code base, stripped out mining, and ran it on top of Tendermint Core. And this basically gave us a project we call Ethermint, which is Ethereum on proof of stake, basically. And so one of the cool things about this is anyone who's used to building Solidity applications and dApps on the EVM can easily migrate their stuff over from the proof of work Ethereum or the hybrid Ethereum over to Ethermint, which is the fully proof of stake Ethereum. But the issue here is you still don't get that sort of fine-grained control that we wanted when building your application, which is one of the reasons we got into this. But at the same time, a lot of people don't want to write their entire state machine from scratch. It's a very daunting problem. So what we did is we created a piece of software called Cosmos SDK. And what Cosmos SDK does is instead of you building your applications as things on top of an existing application, it gives you this sort of bare bones SDK, what we call Basecoin. It's a basic blockchain with tokens, governance, staking, all the basic things you kind of usually want in a blockchain. And then it allows you to add functionality through plugins. And then once you add all your functionality you want, you can easily deploy your chain. We'll be going back into a little bit of more about how this works in a little bit. But one of the cool things now that we have is with all of these chains, all of these ways of building on Tendermint consensus, is we can create an ecosystem of all these chains that are using, since they're all using the same underlying software, Tendermint Core, we've created a protocol called IBC, which basically allows any chains that are using Tendermint to talk to each other and share information amongst each other, share tokens, share data, at some point even maybe contract calls. And so you can have, here we have Chainmint, you can have it talk to a private chain or to Omisco, which is also building on Tendermint. And the Cosmos Hub is sort of a chain that was, also built with the Cosmos SDK, sort of eating our own dog food. And it acts as a routing mechanism for these different chains to talk to each other, as well as it acts as a way to prevent these, if you're sharing tokens amongst chains, it prevents chains from double spending other chains. We'll get into that a little bit. I know it's a little, whoa, chains double spending other chains. But one thing though is this only limited to Tendermint chains? No, because IBC can actually be adapted to work not just with Tendermint chains, but really any sort of system that'll gives you finality. So Tendermint happens to be one of the first systems that's publicly available that gives you finality. But for example, we can easily imagine some in the future, perhaps you can write a Casper version of like a Casper core that complies to the ABCI spec. And we can create this sort of like modular consensus where you can take your application, run it on Tendermint or run it on Casper. And because Casper, similarly to Tendermint, also gives finality, it can also communicate with the rest of these things through the IBC protocol. And now, the other side, what about things that don't have finality, such as proof of work, such as Ethereum at the moment? What we do here is, what we can do is we can declare something called pseudo-finality. Proof of work never gives true finality, but we'll say, in Ethereum, if something gets 100 blocks deep, we'll assume that's good enough. It's not going to be forked at that point. And so from what we can do is we'll create something what we call a peg zone, where it'll be a Tendermint chain, and what it will do, what the participants, the validators on this chain will be doing, is coming to consensus on what's the 100th deepest block in the live Ethereum blockchain. And so what this does is it kind of creates a mirrored blockchain, a Tendermint chain that's mirroring with a delay of 100 blocks, but it's mirroring the Ethereum blockchain. And so the cool thing is, because this peg zone is running Tendermint consensus, it can communicate through everything else in the Cosmos hub in the Cosmos ecosystem through IBC. But how does this, it acts as a mirror, but how do we get logic and data to go between Ethereum and this peg zone? You'd have to create a new protocol, communication protocol. And this is something one of our hackathon participants, June, he's a 17-year-old high schooler from South Korea. He created a protocol called ET-Gate, which is basically a way to allow a peg zone to talk to a smart contract on Ethereum and act as a conduit, as a bridge for getting Ethereum to connect to the rest of the Cosmos ecosystem, which is super cool. And so now let's talk a little bit about the Internet of Blockchains and how Cosmos and Tendermint, what did they do to do this? And so I was taking a class auditing a class this semester at Berkeley called Internet Architecture. This is about the design of the original architecture. And in one of the first few lectures, there was a list of design goals of the internet. And these were the 5 sort of main design goals that were thought of when putting into the architecting the original internet. And what struck to me was like, wow, these are a lot of the same design goals that we have in creating our blockchain ecosystems as well. And so, this kind of like whole intent of blockchains idea is, can we use those kind of things to solve the problems in the blockchain ecosystem as we did in the traditional internet ecosystem? And so let's go ahead and walk through all of these and see how Cosmos and Tendermint work together to help enable these functionalities. So, let's start with the basic one, the one that everyone's super hyped out about right now, because it's a very quickly coming wall that we have to face, is scalability. And so there's two kinds of scalability, basically. One is called vertical scalability, and the other is horizontal scalability. So the difference between these two is vertical scalability is how many transactions per second a single blockchain can handle. So, blockchains such as Ethereum can handle 15 transactions per second. And how high can we push this transaction throughput? Let's say it's 1,000 or 10,000 or 100,000. You can do these. There's a lot of adjustments you can do at the application layer and the consensus layer and even the networking layer for how to do this. And in Tendermint, we try to optimize a lot of the stuff that we can at the networking and consensus layer. And there's a lot more that can be done at the application layer as well, through things like state channels, recursive snarks, a whole bunch of things. But so let's assume that there's a cap on how the scalability of a vertical scalability of a blockchain can be, because there has to be a fundamental cap due to things like the speed of light and whatnot, that pesky thing. So when we get let's say it's 1 million transactions per second, what do we do when we want a blockchain system that can do more than 1 million transactions per second? It's simple. We just create multiple blockchains. If we have X blockchain throughput and we want 10x blockchain throughput, let's just do 10 blockchains, as long as these blockchains have the ability to talk together. So when it comes to vertical scalability, what some of the optimizations we do at the consensus layer and networking layer is, Tendermint is very well designed for great transaction throughput. And so, in our tests, we've gotten Tendermint Core to get over thousands of transactions per second with 64 validators on 5 different continents. And there's a lot of research that we do on how to make this even faster using things like pipeline Tendermint, improvements on the peer-to-peer layer, a lot of cool ongoing research as well. Then there's the horizontal scalability side. And so, the other word you might have heard commonly used to describe this sort of idea is sharding. It's the idea of you create a lot of shards that all basically talk to each other. And so let's say we're creating a sharded blockchain ecosystem. The logical way to shard it, in my opinion, is you do application-based sharding, because it minimizes the bottleneck. When you have a sharded blockchain ecosystem, the transactions that are happening within a shard, the bottleneck in the system is when transactions are going between shards. And so if you do something like address space sharding, for example, like let's say an Ethereum, where you take all the transactions that have 0 as the first byte in the address space, it's in one shard. Everything with 1 is in a different shard. Everything that's 2 in a different shard. But the problem with this is, there'll be a lot of inter-shard communication, which will cause a lot of throughput issues in the bottleneck. So what makes more sense is you do application-based sharding, where you put every application on its own blockchain. And the cool thing about this is that most transactions that are happening within an application stay within that application. And only the few things that are leaving the application, talking to other applications, will go out. And you can try to minimize the bottleneck by doing this. And it's also scalable from another standpoint because, in Vitalik's scalability lemma, he talks a little bit about, if we increase the scale, with multiple blockchains, you get less decentralization because it's harder to run nodes for all of the blockchains. But the key thing that you have to remember is that if each application is on its own blockchain, you really only have to be a full node for the applications you care about. If I'm a user of Storj, but I don't use Golem, why should I be processing all the Golem transactions. I'll just run a node for storage A and for all the applications I run. So I don't really have to have the computational resources to be a full node on the entire system, just the things I use. And there will be enough overlaps in this system where people are using some applications and then others, and then we'll have a relatively strongly connected system where people will be full nodes of multiple applications, just not all of them. And so now here's the claim that I'm going to make. It's a bit of a radical claim, maybe a little bit of an unpopular opinion, but I'm going to make the claim right now that Turing-complete VMs were sort of a mistake. I think that Turing-complete VMs are, I think smart contracts are great for some use cases, for prototyping, I think the word smart contract actually kind of gives it away in a little bit, where smart contracts should be used for exactly that, contracts. The issue comes when we start trying to write entire applications as smart contracts. So if you have, you make a quick financial contract, or you make a one-time use application, writing it on a Turing-complete blockchain makes sense. But if you're building an entire application that's supposed to have a community around it and have a long-term use system, you should probably not be running it on a Turing-complete system. You want to write it into the core logic of the chain, because now if we buy this idea that every application is on its own blockchain, why not optimize each blockchain for its use case? And so this is what the Cosmos SDK kind of does, is where it makes it very easy for anyone to write their own applications. You have the base layer, whatever you need, and whatever functionality you want to add, you add it in as plugins. And there'll be an open marketplace for plugins, basically. Let's say I wanted to make Golem, right? There's basically, simplifying it down, there's two sort of main things we need here. We need a marketplace where people can buy and sell computation, and then we need a verification system, let's say Truebit. And so what we can do if we're building this Golem chain on the Cosmos SDK is we have our base, then we'll go from an open marketplace, we'll pull in a market plugin and a Truebit plugin, put that on our chain, and deploy it, and this will be Golem. And then you can get this flexibility and stuff through governance, where let's say 3 years down the road, ZK snarks become a viable verification method. So what we'll do is through governance, you can just decide hard fork and by pulling in a new ZK snarks verification plugin, and now you have 3 plugins on your chain, and then you redeploy your chain. You just hard fork the chain to have this upgrade. And so this sort of model has a lot of benefits over a Turing-complete model. For one, obviously, you massively reduce the attack surface when the idea of anyone being able to write arbitrary code in your system, it makes it easier for developers to make mistakes, and whatever we can do to make it easier for them to avoid that is better. And so we can avoid things, hopefully, like the DAO and stuff happening. Also, you get a lot of efficiency gains due to less computational overhead. Let's say you're making something as simple as Namecoin. It's a key value store, right? So if you look in the bottom right, this is a opcode set for a project we have called Merkle Eyes, like eyes. And so what this does is it is a key value store on Tendermint. And this is sort of the opcode set that we have for Merkle Eyes. And what you can see here is it's really 7 opcodes. The bottom 3 of them are actually for consensus reasons. So in reality, we only have 4 opcodes needed to make this sort of key value system. This is much more simple and less computationally intensive than an entire VM, basically. And so, if I'm making Namecoin or ENS even, why am I running it on an EVM, which is massive computational overhead? And in proof-of-stake systems, the overhead is limited to, you can get much greater vertical scalability through either decreasing the computational requirements or increasing the network, decreasing network latencies. And so decreasing the computational requirements allows your system to do much more greater throughput. And then finally, with the application-specific chains, you can also fine-tune to optimize for your application. So this is sort of what we were talking about at the beginning, where the EVM kind of limits your control over the system. So for example, Bitcoin, it's UTXO because UTXO in many ways is optimal for payment processors. Payments are generally very stateless system, are not, but Ethereum decided, it was kind of optimizing for the general use case, the average use case. But if you're making a new payment processor, why should you have to settle for the suboptimal system with the account model when you could use an UTXO model, which happens to be optimal for your use case? And so you can do these kind of fine-tuned optimizations to better the performance or user experience of your application, and don't have to be limited to the design choices made by the EVM. And so on top of that is the diversity aspect. In Tendermint, we allow you to write your applications in basically any language. You can write on top. The ABCI spec is completely language agnostic. We have implementations in over 12 different languages. This is just a small subset of them on screen. There's more, such as Haskell and C, I know. And you can connect all the existing platforms that we have, such as what we've already done with Ethereum and Chain. And the Cosmos SDK makes it very easy for basically all these applications to work together. And that was kind of sort of the goal of the internet as well. It's an inter-networking protocol. We had a bunch of different types of, not just different networks, but different types of networks in the original internet. You had Ethernet networks, you had satellite networks, you had mobile networks, and we needed a way for all of them to work together. And each of these different sub-networks was sort of optimized for its own use case. And getting the Cosmos SDK sort of allows, the internet allowed all these systems to interoperate in the same way that the IBC protocol that's used in Cosmos is sort of agnostic to the optimizations that are made for each network for their own use cases. Okay, so now we'll go ahead and talk about the other side, interoperability. So, when Ethereum came around, I think it really brought two main things to the table that really revolutionized the blockchain space. One, it made it very easy for application developers to build applications because the EVM and all the tooling around it made it very easy. And this is something we're trying to model with the Cosmos SDK, making it very easy to build for people to build their own applications, as well as with Ethermint, leveraging all the great tooling that's been built up by the Ethereum community and allowing people to port their stuff over easily. But the other thing that Ethereum also allowed was the interoperability, where applications can talk to other applications. And this is a really powerful feature. And so to do this, what we did was we created the IBC protocol. It's basically a two-way, on-chain, light client protocol. And what this allows is that means that applications and smart contracts on different chains can interact with each other. And so the Cosmos Hub, like I mentioned earlier, acts as a routing mechanism. If Cosmos is the internet and IBC is sort of the TCP/IP of the Cosmos Hub sort of, you can think of it as a ISP. It helps do the routing. The other thing that the Cosmos Hub does, along with the routing though, is it also allows for the deep integration of token economies. So what this means is that you can do these token transfers, not just basic token swaps. And so this is one of the questions I get asked very often, like what's different between this and atomic swaps? And so atomic swaps or decentralized exchanges or all of these sort of things are, what is a swap or a trade? It's two people trading things of different value. If I have X Bitcoin and you have Y Ethereum, if we think they're both worth equal value, we can trade them. I'll get the Y Ethereum, you'll get the X Bitcoin. But you'll notice that this actually doesn't allow value to transfer across chains. Basically, all the value has to stay the same because if there was a mismatched value, then the trade wouldn't happen. So what a token swap actually allows you to do is, using sidechain protocols, we basically take it such that you could take, let's say, for example, your Bitcoin on the Bitcoin blockchain, freeze it in a smart contract, and submit proof of this freezing to a smart contract on Ethereum. And what Ethereum will do is it will say, okay, cool, thanks for this proof. Here's an ERC20 token that represents that Bitcoin that you froze on the Bitcoin blockchain. And so what this ERC20 token is basically a representation of that frozen Bitcoin. And what the cool thing you can do is, unlike one-way sidechain protocols, a two-way sidechain protocol allows you to, your ERC20 Bitcoin, you can burn that, submit proof of that burn to the Bitcoin blockchain, and then allow you to thaw out your original Bitcoin. So unlike, in a one-way sidechain, because there's this like easy way to go back and forth, you make sure that the tokenized representation of the frozen Bitcoin is worth one Bitcoin, because it can always be withdrawn for one Bitcoin again. And so now that we have this sort of Bitcoin on the Ethereum blockchain, we can use Bitcoin on the system. And through the Cosmos system, the tokens will there's not just two chains that are talking to each other, but you can have tokens that are kind of going across many, many different chains. So Bitcoin can exist on, hundreds and hundreds of chains, for example. And this is true for all tokens, really. And so now let's go on to the next topic, but we'll be coming back to the token economies very soon. So let's talk a little bit about sovereignty, right? Well, one of the things that you really want in a system is you want these different blockchains to still be able to maintain their sovereignty. What does this mean is that, for example, Ethereum and Ethereum Classic can't have the same validator set in proof of stake, because the people who are the validators who are operating the network have sort of very fundamentally differing philosophies. And for that reason, it doesn't make sense for them to share the same validator set and act as a single blockchain network. But you still want them to be able to sort of like interoperate with each other. And this is what the Cosmos Hub allows. This is sort of one of the key differences between Cosmos and Polkadot. While Polkadot basically requires you to give up your chain's sovereignty, you have to use the Polkadot validators. And this comes with its benefits, but it loses a lot of these sovereignty benefits. And another great sovereignty benefit that you can get is that you can have private chains that can now interoperate with public chains. Private chains can basically, because they don't have to give up their sovereignty, they can plug into the Cosmos as well and talk to all the other public chains in the system. You can even imagine that private chains become sort of oracles for public systems. Another cool thing about sovereignty is that, if you have a community-run blockchain, you can achieve greater security than pure economic incentives alone. So for anyone who knows, the flag on the right is the flag of a sort of micronation called Liberland. And Liberland is sort of a new country formed in 2014. And one of the things I'm doing is helping them build some of their platforms and tools on blockchain, such as voting systems, land registries, things like that. And so one of the cool things about the Liberland blockchain is, because it'll be run as a proof of stake system, but by the people, the citizens of Liberland, it can achieve greater community power, because, if you assume everyone is a purely economically rational being, then you can get into like bribery attacks and things like that. But if the people running the chain are, have political and social motivations beyond just economic alone, it's much harder to bribe them to do something wrong and that's malicious towards the chain than it would be to attack a economically minded, a purely rational validator. And so through this community power, we can achieve greater security in a way. And then also your governance is controlled by your community. So, when the DAO happened in last year, the Ethereum community was much smaller, and a large portion of the community was highly invested in the DAO, which made it much easier for the Ethereum community to sort of roll back and hard fork to solve that. And even then, they still, not everyone in the community agreed, which is why Ethereum Classic still exists. But now let's fast forward to the last few months or so, when there was another, a very similar situation going on where about $150 million has gotten locked up in a multi-sig, in a lot of multi-sigs, and it would require a hard fork to save that money. But the thing is, only a small portion of the community has actually been negatively affected by the bug. And so it's hard, now it's going to be harder for the people who are negatively affected to sort of convince the rest of the Ethereum community to sort of save them, because they don't make up a majority of the community and they don't have control over the governance. Now, on the other hand, if that community had those funds on their own blockchain and there was a hack or a bug that basically exploited that money away, they only have to get their own community's consensus to undo the bug and fix the problem. And this sort of community, and the ability to do these hard forks is actually a further deterrent of malicious activity. And so, the sovereignty is great. It does come from the other side where, if you don't need chains that are fully sovereign, what you can do is you can kind of chains that are okay with merging their, sharing their validator set can do this sort of pooled security where it can be thought of as almost a proof of stake equivalent to merge mining, where a lot of different chains are using the same proof of stake system to a lot of different chains are using the same proof of stake system to give each other security. So if you get slashed for malicious activity on one chain, you also get slashed for this malicious activity on all the chains. And so this is a great way to bootstrap many chains to join into a larger pooled security system, or to give your entire system much more economic cost in attacking it. So now we'll go ahead and talk a little bit about what are the implications of an internet of blockchains. What kind of changes will we see in the blockchain ecosystem because of this? So for one, we're going to see a lot more interoperating functionality. The features of many different chains will now be able to be interoperated. So, for example, Bitcoin is largely designed to be a payment processor. That's what it kind of focuses on being. Ethereum, meanwhile, is optimized to be a smart contracting system. But if we could use the benefits of both systems, you can use the movement of value Bitcoin transfers through Ethereum smart contracts. And so each chain can kind of focus on what it does best and then work together to create a better user experience in the end. We'll also see many cross-chain tokens starting to begin, where specific tokens will not be limited to a specific chain, but can rather be used across many chains. So let's say we have an application such as Storj. What they will do is they will put they can have a contract on many different chains, and such as they can have one on Ethereum, one on Tezos, one on Rootstock, but they can use the same token on all three of these systems. So if you have your Storj token sitting on Ethereum and you want to use the system on Ethereum, but there's just not enough liquidity or the transaction fees are too high at this moment on Ethereum, you can easily just move your Storj tokens to a different chain, and you can move them over to the Rootstock chain and use the Storj contract there. And so you'll see these sort of cross-chain tokens happening. And one possible effect of this, which quite honestly is something I'm sort of hoping for, full disclaimer, I'm sort of a Bitcoin maximalist when it comes to the currency. I think that Bitcoin is the only thing that has anywhere close to wide mainstream adoption, And so for this reason, I think it is sort of going to be the cross-chain currency. But the Bitcoin blockchain, on the other hand, I'm not a huge fan of the protocol. But what I see the Bitcoin blockchain turning into is sort of a proof of work mint, where the coins are just going to be minted on the Bitcoin blockchain and then quickly moved off onto other chains to do whatever they want, to be used as currencies and stuff. And so this would be an interesting, thing to ponder. Is this the effect that we're going to see? The token that has the greatest network effects, which is quite honestly currently Bitcoin, will it sort of, because it'll no longer be limited to its the shortcomings of its protocol, will it sort of become this cross-chain token and kind of kill off other currency tokens at least? So this is sort of an open question. So now let's talk a little bit about these cross-chain contract calls we've been talking about. So, what we can now do is smart contracts on many different chains can call smart contracts on different chains. So an application can be sort of based on, let's say, a Cosmos SDK chain, but it can make a call to Tezos to gather some identity information, perhaps, and then go to Chainmint chain to get the tokens from a patient's account, move it to the insurance agency's account, and then send all the data back to the Cosmos SDK chain. And you can basically have these like multi-chain contracts that work in a sort of atomic way, the diagram doesn't show it, but this will all be sort of enforced through sort of fraud proofs and things a bit farther down the line, but upgrades to the Cosmos Hub. We can also get this sort of public-private interoperability that can happen, where now private chains can sort of benefit from the usage of from the data and stuff that's available on public chains, but at the same time, public chains can also sort of maybe private chains can become sort of oracles for public chains, where a couple of insurance companies have their own private chains, and they can basically take that private data that's on their blockchain and send it to public chains and act as oracles for bringing real-world data into these public blockchain ecosystems. And so what else big differences will we start seeing? One of the hottest topics right now is decentralized exchanges. And so let's go ahead and see what would happen. A lot of big decentralized exchanges, such as one of the biggest ones right now is EtherDelta. But the thing is, it's very focused on the Ethereum ecosystem, and it only allows you to trade ERC20s. So let's take a look at the coin market cap. This is slightly outdated, about maybe a month or so. You can definitely tell by the Bitcoin cash price. But let's look at let's try to find the ERC20 tokens. So within the top 10 right away, there are literally 0 ERC20 tokens. Okay, let's look on the next 10. So we see our first ERC20 token on number 13 with Omisco. But the thing is, Omisco's not really a long-term ERC20 token. They use an ERC20 token for their ICO, but in the long term, they're moving their system onto their own blockchain. So let's try to find our first real ERC20 token. We finally find our first real ERC20 at number 28 with Augur, which is actually a dApp on Ethereum. But the thing is, if you're building a decentralized exchange that's focused on the Ethereum ecosystem, you basically just missed out on the first 27 tokens of value, which is billions of dollars of market cap. And so if you're building a decentralized exchange, you really want it to be interoperable with tokens from many exchanges, from many chains. And so this is why DEXs such as Kyber Network and Omisco are sort of building on top of the Cosmos ecosystem. And then a final interesting implication just to ponder is A final really interesting implication to ponder is that, like I mentioned earlier, application-based sharding is a very logical way of sharding. But the other thing, like I also mentioned, was network latencies are also one of the biggest keys. Reducing network latencies is one of the biggest keys to vertical scalability as well. And so if we can create these if we create sharding based off of geography, where you can have, let's say, North America hub, where a bunch of chains in the North America region can all talk to each other, and then you have China hub, and then you have a larger hub that basically connects these many smaller hubs, and it sort of becomes a federated system based off of geography. And so the question is, like, what are some of the implications of this? Like, it allows for much greater scalability, but does this lead to more fragility in the system? Part of the original goals of many of these technologies were to become globalized systems, and does geographic sharding sort of take away from these vision? So this is just an interesting question to ponder as well. So hopefully by the end of this presentation, I've managed to show everyone here a lot about all the different, how the Cosmos Hub basically acts as a internet of blockchains and allows all these different existing blockchains and networks to really communicate with each other, and then why we really want this to happen. Like, what will be the benefits for the system and how it will change how this industry works when different blockchains can interoperate with each other and use each other's features to create a stronger, more resilient, and more feature-packed blockchain ecosystem. So thank you all so very much, and please feel free to contact me with any questions you have. You can contact us on email, or you can message at Tendermint Team or at Cosmos on Twitter. So yep, thank you so much, and have a nice day.